Hello. In this video, we will download and install Cisco Packet Tracer. Cisco Packet Tracer is free and available from the website of www.netacad.com. This is the Cisco Networking Academy. You must have an account with Cisco Networking Academy in order to download and install Cisco Packet Tracer. From the website www.netacad.com, I'll hover over the Login button. When you click on Login, you'll be redirected to a login page. Please use your current credentials for the Cisco Networking Academy. If you do not have credentials at this time, you'll have to create an account. After entering your username or an email address assigned with a Cisco Networking Academy account, you'll click on Next. At this time, you'll be asked for an account password. Please type in your password for your account. After entering your password, click the Sign In button. When your account is successfully authenticated, you'll be given a main home page. On this home page, you'll be able to see resources at the top. Hover over Resources. Click on the link for Download Packet Tracer. The Download Cisco Packet Tracer page will load. You can scroll down and find the latest installers for Cisco Packet Tracer. These installers are organized based off of the operating system that each executable has been created for. Please download the latest executable for your system. After downloading the latest available Cisco Packet Tracer installer, locate the executable file that you have downloaded. Mine is in the Downloads folder of my machine. I will double-click on that install license agreement page. I'll click on I accept the agreement and click Next. I will leave the default directory for where it will be placed and click Next. The name of the Cisco Packet Tracer application in my Start menu folder, I'll leave the default and click Next. From here I have two options regarding the desktop shortcut and the quick launch shortcut. I will leave the default settings and click Next. When I click on Install, it's now going to extract the files from the executable file and install the program to my machine. After the installer has completed, the default selection is to launch Cisco Packet Tracer. I will leave that checked and I will click Finish. The installer application will close, but Cisco Packet Tracer is going to open now on my machine. I have a pop-up that is asking to run multi-user when the application starts. I will click on Yes. From here, Packet Tracer is going to load for our initial deployment. Packet Tracer will ask for access through the Windows firewall of my machine. I will check for private home networks, and at this time I will deselect for public. I will click Allow Access. When Cisco Packet Tracer begins to open, it will allow me to log in using my Cisco Networking Academy credentials. This is very important as it allows me to be able to save files more than 3 times. If I do not log in using my Cisco Networking Academy credentials, I continue as guest. That is a limited alternative compared to using your Cisco Networking Academy credentials. So I will enter my credentials for the Cisco Networking Academy. I will click on Next and it will ask me for a password. I'll enter my password for my Cisco Networking Academy account. And before I click Sign In, I will check mark the box to keep me logged in. This allows my machine to utilize these credentials for up to 3 months. It means I don't have to log in every time I open Cisco Packet Tracer. With that check mark selected, I will click Sign In. At this time, the Cisco Packet Tracer application is installed, and now I can begin designing, configuring, troubleshooting, and deploying networks, IoT, security, and more. Hello everyone, welcome to our Getting Started in Cisco Packet Tracer walkthrough video. In this video, I get to show you the different features built inside of the program known as Cisco Packet Tracer. As we get started, we'll highlight some of the key components of using the Cisco Packet Tracer application. Let's begin by taking a look at the bottom toolbar, and I'm looking in the bottom left corner. Here we have a variety of different categories, and in each category, we're going to have options below. For example, the default category is network devices. That's selected by default. In the network device category, we'll find the subcategory of routers. With routers selected, we'll see a variety of different model routers available for us to put into our topology. If I click on the next item, it's switches inside of our network device category, and then my list will now contain network switches that I can deploy inside of my topology above. The next category is hubs, followed of course by wireless devices, including then the next category of security, and then finally is WAN emulation for our wide area networks. Outside of the network device category, we can find the next main category of end devices. If I click on end devices, our default subcategory is an end devices of different types of host and other equipment we can put on our network. There's another subcategory for end devices, which is home. And this brings in a lot of our smart network-enabled IoT devices. We can go further by looking at city-wide devices, which are under the category of smart city within end devices. If we continue on, the next component will be industrial, and then even power grid, all bringing some great features into Cisco Packet Tracer and the type of devices we can deploy in a network. To go even further into the realm of Internet of Things known as IoT, we have another main category known as components. And in components, you'll find a variety of different boards. Also, we have another subcategory for actuators and even sensors. These can be deployed in a network just like what we're doing now. To interconnect your devices, we'll be utilizing the connections category. In the connections category, we have two subcategories. We have connections, which is our common type of cabling we'll be using, but also another subcategory is structured cabling. And here you will find items that are available in physical view of Cisco Packet Tracer, and these will include patch panel connectors and wall mounts. The next category is miscellaneous, and here we will find some custom-made devices already installed. Lastly, the category of multi-user connection allows us to interconnect our Packet Tracer instance with others across a local area network or even a wide area network connection. Let's continue by creating a small network utilizing our Cisco Packet Tracer logical view. By default, we can see our Packet Tracer is open in the logical view mode. This is where we can build a logical topology. I'm going to select the main category in the bottom toolbar of network devices. The default selection again is routers, and I'll go ahead and take a look at the routers available. At this time, I may want something like a 4331 Cisco router. I can click on that, and then I can click in our logical topology. I can continue by deploying now a network switch. I will click on the subcategory for switches, and I'll click the first switch available. I will then click on my logical topology, and now it is ready. At this time, I'd like to add on 2 or 3 end devices, so I'll click on the category of end devices. The default subcategory of our end devices is already selected, and I will go ahead and take one PC and click it on, put it right in the logical topology, and one laptop. I will click and click on the logical topology. At this time, I'd like to interconnect these by utilizing our cabling. That is under our Connections category. I will click on Connections. The default subcategory of Connections is already selected, and I will choose the appropriate cabling to interconnect these devices with the router and switch. I will use my straight-through cable, which is the third option available. I will select it, click on my PC, choose the corresponding port of Fast Ethernet, and connect that to the switch. I can choose any available interface for network connectivity. I will repeat this by connecting the cable from the laptop, Fast Ethernet, to the switch on another available network interface. Lastly, I'll interconnect that switch to the router in our logical topology. I will grab the appropriate cable by clicking on it, click on an available port on the switch, and then connect it to the router on an available network connection. You will see indicator lights being shown here due to port status and connectivity. At this time, we have a small logical topology built. We will take a look at the physical topology of how we will be able to build a network and interconnect them in a physical view. I will click on the Physical tab, and you'll see a change. The change is our screen is a little bit taller. The bottom toolbar might be in the way. We will have our ability to scroll on the right side of our screen by the sliding tab. We can see that there's the PC that I have clicked and put in the logical topology, along with the cable coming off of it. Also, we can see the laptop has been positioned on top of the PC. I can click and drag it and put it on the table next to the PC. If I scroll up, you'll see those cables from the PC and the laptop connecting to the switch. I can click and drag the switch, and I can lower it on our network rack. That switch is connected to the router. I can click and lower the router on the network rack in order to organize these devices and cabling better. In the physical view, I have the ability to use my main toolbar, and I have settings for zoom. I will click the magnifier glass with the plus to zoom in. Now you have a better view of the physical router with the cable that connects to the physical switch, and then if I scroll down, the physical switch with the two connections to the devices down below. If we want to manage our cabling, we'll right-click on a network cable and we'll be presented with three options. We can delete the cable to remove it completely. We can color the cable a different color so we can identify the cable and thus identify any devices connected by that cable easier. Or we can select Manage Cable, which will take the cable and will put it away nicely, which provides us a nice and tidy workspace. In the real physical world, that would allow us to organize our cabling, secure them appropriately, and keep them from disconnecting or from being crimped. We cannot use Manage Cable at this time for any devices sitting on a table or on a shelf. We can only use this Manage Cable option when devices are on our network rack on the left side. At this time, I'll scroll up to the top, and you can see that we have our switch and our router. I can right-click on the switch, and I can say Manage All Cables on Device. When I select that, you will see that the cabling between the switch and the router looks like it disappears. Instead, that it's just keeping our cables nice and tidy between the actual switch connection to the upstream router connection. If I right-click on that switch again, you'll see we have the options to inspect front, inspect rear, to delete the device, or to unmanage all cables on the device as well. By unmanaging all cables on the device, we see the interconnected cable between the router and the switch reappear hanging down on the front of our network rack. If I right-click on that switch and select Inspect Front, we'll get a closer view of our network switch. Again, we have our magnifier glass options to zoom in. I will click on Zoom In, and then I will scroll to the right and down with my packet tracer window. We can see that I have port 10 on the switch connected to a device. If I hover over that connection, we'll see it's connected to device PC0. We'll also see there's a link light on for port 20. If I hover over that connection, we'll see that this connection goes down to the laptop. And lastly, if I hover over the gigabit connection on the far right side of the switch, we'll see that this connects to device router 0. This is great information for us to be able to document and visualize our interconnected physical network. But also, if I close this off, again, we can just follow those cables and see where they interconnect to the devices. If I right-click on the switch, we can also select Inspect Rear. When we click Inspect Rear, we will get a rear view of the Cisco switch. Again, I'll use my magnifier glass, and we will be able to click and zoom in. Here we will see the console connection for us to complete our initial configuration of the switch. Also, you'll notice that there's no power button on the Cisco switch because the Cisco switch is automatically powered on once it is connected with a power cable. To remove power, we would unplug the Cisco switch from any power source. If I scroll back to the left side, we can do the same with router 0. We can right-click and inspect front, and we can zoom in and get a better view of the Cisco router and any connections, as well as any available slots that we can install any new components or additional features on. I can right-click on the router again and click on Inspect Rear. And again, I'll zoom in. And here on the router, we can see that we have an aux port, we have our console port, as well as we have a management interface. On the right side, we'll see that we have a power button and the current status of the router is powered on. If I click the power button, the green light will turn off and the power is now disabled for the router. I click it on again, and now the router is actually booting up since it has received power. I will click the X to close the rear view of the Cisco router. If we want to deploy new devices onto this current physical topology, we will use our bottom toolbar. I will select End Devices, and in the End Device subcategory, I would like to deploy a server. I can click on the server, and I will click on the network rack. That server is now deployed on the network rack. We can see that it is powered on and that we have a network interface ready for connection. I will go ahead and click on Connections, and I will click on a straight-through cable. When I click on the straight-through cable, I will click on the network interface card for Fast Ethernet 0 of the server, and then I will click on any port I would like to connect it to. If I want a closer view of what port I'm connecting it to, I can always right-click on the switch and click Inspect Front and zoom in for a closer view. With the zoomed in front of the switch, I can easily identify what port of the switch I would like to connect to. For example, I would like to connect to port 24, which is FA0/24 on this 2960 switch. When I click on that port, the cable is now connected. If you feel that the cable is getting lost, you can always right-click on that cable and change the color as we mentioned earlier. I can make it red, for example, and click OK. And now it's much easier to find the connection from the server to that Cisco switch. This is the power of Cisco Packet Tracer utilizing the logical and the physical views. Please practice and enjoy using Cisco Packet Tracer for all of your network configurations and for any scenarios that you could possibly imagine and build.
This is the world. Always moving, always changing. And nowhere is that more true than in technology. From the very start, we've been on a quest to make things easier, move faster, and expand our opportunities. And with each new innovation, the pace of change has only accelerated. To keep up, education has to advance and evolve as well. At Cisco Networking Academy, we believe that powerful learning comes from hands-on instruction with real equipment and software. So we're committed to giving our students a real-world grounding in today's most valuable skills. We've developed many of our own tools, including simulators that help them test their ideas at scale in different environments. And we keep it real by giving students the chance to test their skills in competitions and hackathons. They receive personalized feedback every step of the way, and not just from instructors. Automated, performance-based feedback is an integral part of the learning experience. Our classes are translated in up to 20 languages, making it easier to learn in your own language and share experiences with others around the world. More than technical skills, it's a broad-based program focused on creating global problem solvers, ready to move the world forward. Our students become T-shaped professionals, meaning they get deep technical knowledge in at least one or two high-demand job areas. But they also get the broader range of skills needed to collaborate across related technologies, which makes them even more valuable to potential employers. Preparing students to become the innovators of tomorrow, capable of successfully contributing to multidisciplinary teams that are setting the pace for the future of networking, the Internet of Things, security, programming, and information technology. They learn from the best trained instructors and earn certifications that can get them better jobs, higher pay, and a well-rounded career, meeting today's needs and tomorrow's opportunities. There's no saying where technology will take us next, only that the ones leading the way will have the T-shaped skills you get at Cisco Networking Academy. It's how academies, educators, and students keep ahead of an ever-evolving world. Discover the latest courses and set out on an exciting career journey at netacad.com.
You're gonna have to call me back.
Did you guys book this room? Because I'm pretty sure I booked this room.
Let's examine the Cisco iOS command modes. I'll click on PC1, click on the Terminal Emulation Program, click OK, and you can see that I'm presented with a console command line interface. This is the Cisco iOS. I'll press Enter on my keyboard to get started. Notice the command prompt at the bottom left of the screen, which indicates the command mode that I'm in. The Cisco iOS uses different command modes to establish various privilege levels for users. Different commands are available in each mode. For instance, the word switch, which is the default name of the switch, with the greater than sign indicates that I'm in user exec mode. User exec mode has very little privileges with access to only a limited number of commands. One of those commands available in this mode is the enable command. At the blinking cursor, I'll type the command enable and press enter, and I'm now in privileged exec mode. I can tell this because the prompt has changed from a greater than sign to a hash or a pound sign. Privileged exec mode offers a higher privilege level for the user and more commands are available. If I would like to go to a higher level, I can go into Global Configuration Mode, or Global Config Mode for short. I can reach Global Config Mode by typing in Configure Terminal and pressing Enter. And now you can see the Global Configuration prompt. This is where most configurations of a switch or a router take place. There are also sub-configuration modes like Interface Configuration Mode. If I type Interface VLAN 1 and press Enter, I'm presented with a prompt that indicates I am now in Interface Configuration Mode. Many commands will only work from within certain modes. A common mistake made by users new to working with the Cisco iOS is trying to use commands from within the wrong mode. If you are sure that you are typing a command correctly, but you are continually getting an error message, always check your prompt to make sure you are in the right mode. Let's look at the commands that are used to move between the different iOS command modes. We'll look at the enable command, the disable command, configure terminal, exit, and using Control-Z on your keyboard, plus some commands to enter different sub-configuration modes. I have a console connection to a switch, so I'll click on PC1 and press Enter, and it takes me to user exec mode. Notice the prompt at the lower left of the screen. To enter privilege exec mode, I type enable. If I want to return back to user exec mode, I can type disable. I'll type enable to return to privilege exec mode. In order to configure the switch, I need to first get to global configuration mode or global config. I'll type configure terminal, and you can see now that I'm in the global configuration prompt. I can type exit and press enter to return to privilege exec mode. If I type exit again, I leave my console connection altogether. To re-enter the switch and get a command line interface, I have to press enter on my keyboard, and now I'm brought back to the console connection with the switch. I'll type enable and press enter, and then config T, short for configure terminal, and now I'm back in global config mode. Let's enter one of the sub-configuration modes. I'll type line console 0 to get to the management interface for the console port. Now that I'm in a sub-configuration mode, if I type exit, I return to global config mode. This time I'll type line VTY 0 space 15 for my virtual terminal management interfaces. These are used for remote administrative access to the switch. I can move directly from one sub-configuration mode to another. Notice if I type in interface VLAN 1 and press enter, that my prompt has changed from line configuration mode to interface configuration mode. From here, I can also enter different interfaces, like interface fast Ethernet 0/1. And as long as I don't see an error message that I've typed an invalid command, I'm in interface config mode for fast Ethernet 0/1. I can also move directly to the line console 0. Commands that are normally run in global config mode can also be run from any of the sub-configuration modes as well. If I want to exit out of all sub-configuration modes and return to privileged exec mode, I can use the N command or press Ctrl-Z on my keyboard. Let's give that a try. I'll type end, press enter, enter again, and you can see now that I've returned all the way back to privileged exec mode. I'll return to global configuration mode and then into line console 0. And this time I'll hold down the control key and press Z. And if I press enter, you can see that I'm brought all the way back to privileged exec mode. If I'm in global configuration mode and I type end and press enter, I'm also brought back to privileged exec mode. Learning to navigate efficiently between the different command modes will save you a lot of time.
The Cisco IOS help command is accessed by using the question mark. The help command is context sensitive, so it matters how and where you use the question mark. For instance, let's say I want a list of all the commands that are available to me in user exec mode. I simply type a question mark and I'm returned the commands that are available in user exec mode. If I type enable and enter privileged exec mode and put in a question mark, I'm given the commands that are available to me in privileged exec mode. I'll press the space bar to get the next page of output. An even different set of commands is available to the user in global configuration mode. Notice I'll go to global config mode, put in a question mark, and I'm given a completely different set of commands that are available in this particular command mode. There are other uses for the help command as well. Let's say that I don't want a listing of all of the commands that are available, and I just want help finishing one particular command. For instance, let's say I'm putting in the command interface, but I've forgotten what the complete command name is. I've typed IN, and I need help finishing the command. I can put in part of a command, and then put in a question mark, and it'll help me finish the command. Notice that I put in IN and then a question mark, and the help command has returned that the command that I'm looking for is interface. I can use the help command in another context as well. So now that I know that the command is interface, let's say I'm not sure what the next command parameter or argument is that goes with the interface command. In this case, I'll put a space and then a question mark, and it'll tell me the next parameter or argument that is required by the interface command. Now I know that the next part of the command is either the name of the interface, like Ethernet, Fast Ethernet, Gigabit Ethernet, or maybe it's VLAN or range. Related to the help command is the command syntax checker. The command syntax checker will let me know when I have a problem with the command that I've put in. For instance, we can see here that the next part of this command would be one of these arguments here. Let's say I make a mistake and I type in the number 33 instead of VLAN or range and hit enter. Notice that the command syntax checker has informed me that beginning at the number 3, I've made an invalid input. This is extremely useful because it helps me to isolate where the problem is with the particular command that I've entered. This can work in different contexts as well. For instance, let's say that I've put in just the letter I instead of interface and I hit enter. The command syntax checker informs me that the letter I is an ambiguous command. The reason being is that if I type in I and a question mark, there's actually two commands that begin with the letter I in global configuration mode, the command interface and the command IP. The third example of the command syntax checker is when I type in interface and hit enter, and the command syntax checker has informed me that the command is incomplete. To solve this, I put in interface again, a space and a question mark, and I'm given the next set of options that I need to finish this command. You can see how the help command is very useful in learning the different commands that are available to you, as well as the correct context and use of the different commands.
Support for hotkeys and shortcuts makes the Cisco iOS extremely efficient. Making use of these will save you lots of time when you're configuring devices. I have a console connection to a switch, however, instead of using the terminal emulation program to console in, this time I'll click directly on the switch and go to the CLI tab. If I press enter, I'm taken to the command line interface. This is a convenient shortcut to the CLI available to you within Packet Tracer. The first hotkey that I'll talk about is the tab key or tab completion for automatically completing your commands. You can use it like this. To get to privileged exec mode, I would normally type the command enable. With tab completion, you simply type the first few letters of the command, in this case EN, and press the tab key on your keyboard, and the command is automatically completed for you. This is very useful. Now this will work if only one command begins with the letters EN. For instance, if I want to put in the command configure for configure terminal and I type CON and press tab, it doesn't work. The command isn't completed. That's because if I put in a question mark, you can see that there's more than one command beginning with the letters CON in privilege exec mode. If I want to use tab completion, I'll need to type CONF and press the tab key, and you can see now the command is completed. For terminal, all I need to do is type the letter T and press the tab key, as there's only one argument or secondary command that follows configure and begins with the letter T, so the switch knows that the command I want is terminal. Even better than using the tab key is command shortening. With command shortening, instead of pressing the tab key to complete the command, you simply use the first few letters of the command, and the iOS will accept the shortened command without hitting the tab key. This is extremely useful. For instance, instead of typing the command interface fast Ethernet 0/1, which is a very long command to type, I can shorten the command to just INT, which is short for interface, F, short for fast Ethernet, and 0/1, and press enter. The iOS automatically knows the command I want and executes it, though you won't see it displayed as you do with the tab completion. Command shortening can make you even more efficient when configuring devices. Sometimes it's necessary to repeat commands. The fastest way to do this is to cycle through your command history using your up arrow and down arrow keys. If I type END on my keyboard and press enter to go back to privilege exec mode, and then I press my up arrow key, you can see that there are two commands in my command history. Pressing the down arrow key will take me forwards in my command history. This is very useful for commands that are used repeatedly. Now let's take a look at some hotkeys. Both Control+Z and Control+C will take us back to privilege exec mode. If I hold down Control+Z and press enter, you can see that I'm back to the privilege exec prompt. Control+C will do the same, and it can also be used to abort certain commands. For instance, if I type CONF and T and then change my mind, I can press Control+C and the command is aborted. Control+A will jump the cursor to the beginning of a line. I'll type configure and then press Control+A, and you can see that the blinking cursor is now back to the beginning of the line. If I press Control+E, the cursor jumps to the end of the line. Control+Shift+6 is another useful key combination. This sequence will interrupt the execution of a command after the command has already been entered. Let's say, for instance, I mistype the command configure and press enter on my keyboard. The iOS is trying to translate the letters that I typed into an IP address. So instead of being stuck in this situation, I can simply press Control, Shift, and 6, and the command is aborted. Lastly, there may be times when you are working on the CLI of a device and an event occurs which generates a message interrupting the command you are typing. This can be very annoying. If this occurs, press Control+R on your keyboard to return to the prompt where the partial command will be displayed, allowing you to finish typing. This sequence is not currently supported in this version of Packet Tracer. I'll simulate the use of these hotkeys by consoling into a physical switch and shutting down an interface on the switch while I'm in the middle of typing a command. I'll press Enter and type Enable to get to Privilege Exec mode, and then I'll go into Global Configuration mode. Let's say I want to enter interface G0/1. I'll start typing the command, and now I'll shut down an interface. You can see the message displayed across the screen. If I simply press Ctrl-R, I return to where I left off, and I can keep on typing. Now that's sweet. Using hotkeys and shortcuts is a great way to save you time when working with the Cisco IOS. When installing a device on a network, it's important to secure access to the device so only an administrator will be able to access it and make changes. To do this, we'll need to perform some initial configuration settings. I'll click on PC1. I'll click on the terminal emulation program, and now you can see that I have a console connection into the switch command line. I'll press enter, and this takes me to the command line interface. As you can see, I'm logged into the switch in user exec mode. No password was required to access the command line. This is a security risk. If I type the enable command, you can see that I have now entered privilege exec mode, also without any type of authentication. This presents a great security risk since from privilege exec mode, I have access to configure the switch. The first thing you'll want to do is secure access to both the console connection and to privilege exec mode. First, I'll control access to the console connection. To do that, I'll get into global configuration mode with the config t command, and then I'll type in line console 0 to enter line configuration mode. I can now put in a password for my console connection by typing the command password and a password of Cisco. For ease of this demonstration, I'm using simple passwords, but you'll want to use strong, complex passwords whenever possible. I'll type in the login command, which will require the password prior to entering user exec mode. Next, I'll secure access to privilege exec mode. To do this, I'll type exit to return to global configuration mode. Then I'll enter the command enable secret followed by the password class. The secret parameter that I used assures me that the password class will be encrypted in the configuration file. Let's see if our passwords have been set correctly. I'll do a Control-C to get to privilege exec mode, and then I'll exit the switch. Now when I press enter, I should be prompted for a password before establishing a console connection, and it does. This password should be Cisco. As I type in the password for security purposes, you won't be able to see any characters. If I type it incorrectly, it should take me into user exec mode, and it does. And from here, I'll type enable, and you can see that now I'm prompted for another password. This time I'll type in class and press enter, and you can see now that I'm in privilege exec mode. Only those with a knowledge of the correct passwords will be able to configure this device. Let's take a look at our running configuration file up to this point. I'll do that by typing in the command show running config. You can see at the top of the running configuration file that the enable secret password has been hashed within the file. To see the rest of the configuration, I'll press the space bar on my keyboard and I'll go down towards the bottom where you can see the configuration for the console line. Here, it shows a password of Cisco and you can see it in plain text. We'll change this a little later. Now that I've secured access to the console port, I'll also want to secure virtual terminal access for remote logins. From global configuration mode, I'll type in the command line VTY and then how many lines I want to allow remote access to. The Cisco switch supports 16 simultaneous remote logins through virtual terminals. To configure all 16, I simply type in 0, a space, and 15 and press enter, and then I'll put in the command password Cisco and then login. Let's take a look at these passwords in our running configuration file. I'll do a Control-C to get to privilege exec mode, and then I'll do a show run, which is short for show running config. I'll spacebar all the way down to the end, and you can see under the configuration for the console line is the VTY line configuration. The iOS automatically breaks this down into two groups, the first 5 lines 0 through 4, followed by the next 10 lines 5 through 15. As with the console password, you can see that the VTY line passwords are also seen in plain text. We can add greater security to the switch if we can encrypt these passwords so that they are obscured in the configuration file. To do this, I'll go back to Global Configuration Mode, then I'll enter the command service password encryption. This command will put a light level of encryption on all passwords on the switch. To verify that password encryption has been set, I'll exit Global Configuration Mode, and type show run to view the running configuration file. If I spacebar down to the end, you can now see that the console password as well as the VTY line password has been encrypted. Another important initial configuration command is setting a banner message. This is a message that will be presented to users when they log in and serves as a legal warning for any would-be hackers. To do this, I'll go to Global Configuration Mode, and then I'll type in the command banner MOTD. That stands for Message of the Day. The message that I type will need to be framed between two delimiters or characters. Just make sure that whatever character you choose is not used within the body of your message. For instance, I'll use a £sign for my delimiters, and then in between, I'll put in the message authorized access only. Violators will be prosecuted to the full extent of the law. And then I'll end it with another £sign. And now the banner is set. Now let's verify it. I'll do a Control-C and then type exit to leave the switch, and then I'll press enter. Notice that I'm presented with the banner warning I just typed in, as well as a request for a password just to get access to the console. I'll put in the password Cisco and press enter, and now I'm in user exec mode, and then I'll type the command enable, and I'm asked for another password to reach privilege exec mode. I'll type in class, and now I have full access to the switch.
After you've begun some initial configurations on your switch, you'll want to know how to save your configuration. You can see that I'm using Packet Tracer and I have a command line interface to the switch. Notice the banner message and that I'm being prompted for a password. I'll put in the password Cisco, type enable, password class to get to privileged exec mode. I'll type in configure terminal to get to global config mode, and I'll set the host name of the switch to S1. To save the configuration on the switch, I'll go back to privileged exec mode by typing exit and pressing enter. And then from privileged exec mode, I put in the command copy running-config startup-config. This command means copy the running configuration to the startup configuration file. The running configuration is the currently working configuration that's running in RAM memory. The startup configuration file is stored in NVRAM memory. The difference is that RAM is volatile and NVRAM is non-volatile, so if you copy the configuration to NVRAM, it will be available when the switch is restarted or reloaded. So I'll press enter, and you can see that I'm prompted for the destination file name. The default name is startup-config, and you can see it between the brackets. I'll press enter to accept the name within the brackets. My configuration is now saved. I can verify the location of my saved configuration file by putting in the command dir for directory. I'll put a space and a question mark, and you can see that there's two different types of storage that I have access to: flash memory and NVRAM. Both of these are non-volatile. The flash memory holds the iOS operating system, and the NVRAM holds the configuration file. I'll put in NVRAM and a colon and press enter, and you can see there's the startup-config file. Now if I was to reload the switch or incur a power failure, my configurations will remain. I'll press the arrow keys on my keyboard and do an up arrow to go back to the command copy running-config startup-config. There's an easier way of typing this command with command shortening. Instead of having to type out running-config and startup-config, I can simply type copy run start, and command shortening will finish the command for me. If I reload the switch, I'll put in the reload command, proceed with reload, I'll press enter to confirm. We'll see that after the switch reloads, that the host name will remain S1, and we should see the same banner message. You can see there's the banner message. I'm prompted for a password. This indicates that the configuration was saved, and the host name or device name shows up on the command prompt, also indicating that the configuration was successfully saved and reloaded upon startup. If I wish to erase the configuration, I'll type in enable, put in my password to get back to privileged exec mode. I can put in the command erase STA. I'll press the tab key to finish the command, and the full command is erase startup-config. I'll press enter, and I'm given a warning. Do I want to really do this? Do I want to continue? The default answer is confirm, so I'll press enter. You can see the message output to the screen indicating that the NVRAM has been altered, or in this case, erased. I can now reload the switch, and this time, upon reload, it should take us directly to the switch command prompt without any authentication required or banner message. I'll press enter, and you can see that I'm brought directly to the switch command prompt. The host name S1 is no longer there, nor banner message, nor line console 0 password required. Let's say I make some changes to the switch. For instance, I'll type enable and config T to get to global configuration mode, and I'll change the host name to my switch. You can see the device name is now my switch. I'll exit and save the configuration. So the running configuration has been saved to the startup configuration file. Now let's say I continue with some additional configurations. I get to global config mode, and I set a line console 0 password to Cisco. I put in the login command, and let's say I change the host name one more time, this time to S1. Now I've made these changes. Now the current state of the switch is that it's running the latest configurations in running configuration. That means the latest configurations are running in RAM memory. Let's say I'm no longer happy with the configurations I've just added to the switch, and I want to go back to the last saved state. The last saved state is where the device name was named my switch. I've changed it now to S1 but I haven't saved the configuration. I can revert back to the previous saved configuration by exiting to privileged exec mode and copying, in this case, not the running config to the startup config, but the opposite. I'll copy the startup configuration to the running configuration. This will load the startup configuration file into RAM and make it the new running configuration. I'll press enter and I'll accept the default. And you can see that the switch has changed names back to my switch. The startup config was loaded into the running config. This does not completely erase the running config, but rather the configurations in the startup config will be merged into the running config. Knowing how to save your configuration and erase a configuration and reload the switch is an important skill to master.
In this video, I need to verify that the IP addresses 192.168.1.2 and 192.168.1.3 have been assigned to switches S1 and S2. These IP addresses should have been assigned to the default switched virtual interface or interface VLAN 1 on both switches. In order to verify this, I will first connect a console cable from PCA into switch S1. I click on the console cable, I click on PCA, and connect it to the RS-232 serial port, and then stretch the cable to switch S1 and connect it to the console port. Now I'll click on PCA, click on the terminal emulation program, and click OK to accept the default configuration settings, and this should take me to the command line interface on switch S1. From here, I'll type enable to switch to privilege exec mode, and then I can issue the show IP interface brief command to examine the interfaces on switch S1. I will need to press the space bar in order to view the full display. At the end of the output, you can see interface VLAN 1, and it has an IP address of 192.168.1.2. However, if you look in this column, you'll see that the state of the interface is administratively down. This means that that interface is in a shutdown state. You can also see that the line protocol of the interface is also down. In order to correct that, I first need to go into global configuration mode. Then I'll go into interface configuration mode for interface VLAN 1.
And I will issue the no shutdown command, which will activate the interface. And you can see that I'm immediately presented with a message that indicates that the interface has changed its state to up. From here I press enter, Control C, and enter again to return to privilege exec mode. And now I can use the up arrow on my keyboard to reissue the show IP interface brief command and then verify that now the state of that interface is up and up, meaning that it is physically up and the line protocol is now up. Next, I will verify the switch virtual interface configuration on S2. To do that, I will connect a console cable from PCB's serial port into the console port of switch S2. Click on PCB, go to the Desktop tab, open the terminal emulation program, accept the default configuration settings, and then that should take me to the command line interface of switch S2. From here, I will enter privilege exec mode and then issue the show IP interface brief command to examine the interfaces on switch S2. You can see at the end of the output we have interface VLAN 1, and at this point it has not yet been assigned an IP address. To assign an IP address, I will first enter global configuration mode and then interface configuration mode for interface VLAN 1, and I'll assign the address by using the IP address command and give it the address 192.168.1.3 followed by its subnet mask. In order to activate the interface, I will use the no shutdown command, or no shut for short, and you can see that the interface has changed its state to up. From here, I will do Control C and press enter to return to privilege exec mode, and again reissue that show IP interface brief command. Press my space bar, and at the end of the output I can see that interface VLAN 1 has been assigned the IP address 192.168.1.3, and the state of the interface is up and up.
To test the connections between all of the devices, as well as the IP address assignments on both switches and both PCs, I'll use the ping command. To do this, I'll click on PCA, click on the command prompt, and I'll begin by pinging switch S1. I will issue the ping 192.168.1.2 command. And you can see from the display that the first ping request timed out. However, I got successful replies for the last 3. This response is typical when you're first testing a connection, and the reason for which goes beyond the scope of this demonstration. If I arrow up and recall that ping command, you'll see that now all 4 echo request packets receive a reply. Next, I'll test connectivity between PCA and switch S2 by issuing the ping 192.168.1.3 command. Again, you can see that the first request timed out, the last 3 were successful, and if I recall the command, I get 4 successful echo replies. Next, I'm going to test connectivity between PCA and PCB. To do that, I will ping 192.168.1.11, PCB's address, and you can see that I got responses for all 4 echo requests. It's also a good idea to test connectivity in the reverse direction. To do that, I will click on PCB, click on the command prompt, and I will issue a ping command back to PCA at address 192.168.1.10. And you can see that I get a successful response when I ping from PCB back to PCA. It's always a good idea to test connectivity in both directions when working on a real network, because if you can ping from one device to another but not in the reverse direction, it usually indicates that there is an issue with your firewall, and by default Windows Firewall will block ICMP echo requests and needs to be turned off.
This is how we see the network. Using topology diagrams, we can see the devices in the network, including end devices, such as desktops and servers, and intermediary devices, such as switches and routers. These diagrams may also contain detailed information about a device, such as the MAC address of the Ethernet and wireless NICs, IP or Internet Protocol address information, default gateway addresses, and addresses for the DNS server. By the way, don't worry about what these terms and addresses mean right now. All of this will be explained throughout this course. This is how we see the network. But how do devices see the network? You can think of it as every device being in its own bubble. The only thing a device knows is its own addressing information. In other words, this is how a device sees the network. It doesn't. So, how does a device know its IP address and what network it belongs to? How does a device know if the destination device that it needs to send information to is on the same network or another network? If the destination is on another network and the information has to travel through intermediary devices, how does the source device know where to send it next? How does the source device know if the information it sent was received or if it needs to resend anything that might not have reached the destination? The answer to all of these questions is protocols, the rules that govern how devices communicate. Most network communications are broken up into smaller data units, which we can refer to as packets. When packets are sent on a network, many protocols are involved to help them reach their final destination, each accomplishing a different task. There are protocols such as Ethernet and wireless protocols that physically connect the device to the network. The protocols DHCP and ICMP-v6 provide IP addressing information, including IP addressing that tells the device what network it belongs to, the address of the default gateway that tells the device where to send packets that are destined for another network, and the address of the DNS server for when a device knows the domain name of a destination but needs the destination's IP address. For instance, when a user requests a web page from a web server, such as www.example.com, the device asks the DNS server for the IP address of the domain name www.example.com. IP is used to deliver the packet from the source of the information to its final destination, in this case the web server, similar to sending a letter. The web server will then respond back with the requested web page. TCP is a protocol used to guarantee reliability. In other words, to make sure all the information that was sent was received, such as the information that makes up the requested web page. If any of the IP packets don't make it to the destination, TCP resends them. So although we see the network like this, remember, it's a combination of many different protocols that allow devices to really see their place in the network
and how to communicate with other devices.